Alright, hello everyone, you're welcome back to my channel. Some days ago we started looking at solutions to these problems of Math 201, and we got to page 5, which covered from questions 1 to 3. Alright, so in this video we are continuing with question 4. Okay, and then the first one here, which is A, says find a vector W that is orthogonal to both U and V, where U is -642 and V is 315. Okay, so of course there is a hint here which makes it very simple for you, but even without the hint, I know I've taught you that for two vectors, any two vectors at all, to be orthogonal, then their cross product must be equal to the cross product of the two of them is the vector that will be orthogonal with the two. So all that person is actually asking you to get is the cross product of the two vectors. All right, and that we are able to do. So let's look at it. So we bring in our u is -642, our v is 315. Okay, so that's going to give us I into 4 times 5 is 20 minus 2, then minus j. Of course, you know you are going to alternate signs here. You have plus minus plus, right? So minus j into you cross out this, so you're going to have -6 times 5, which is 30, minus 2 times 3, which is 6, and then finally you have plus k, and for k you have -6 times 1, which is -6, minus 3 times 4, which is 12. Okay, so from there you would get that 20 minus 2 is 18i, and then minus 30 minus 6 is minus 36, multiplied by minus j will give us plus 36j, and this last one will give us minus 18k. So in other words, this is the vector that will be orthogonal to u and v, and you can as well put it in the bracket form, which is 18, 36, 18. Minus 18, and that's your solution there. All right, so we go on to the next one, which is B. So B says that we should find at least two vectors that are orthogonal to the vector u, and this is the vector u here. So remember, I wouldn't be writing the questions here, but of course I'll be reading. I know you have the material already. Okay, so there are two ways you can actually handle this. One is you can use a trial and error approach, which is to try to get an arbitrary vector that the dot product with this will be 0. Of course, you can try that. For instance, let me call the first vector. Remember, they said we should get 2. So let me call the first vector v. All I need to do is to look for a number I will multiply with 2, and then another number that will multiply with 3, and two of them will be the same magnitude but opposite, since this 3 is already negative. And then the third one, I'll just make it 0 and then save myself the stress. So if for instance, if I make the first vector here 3 times 2 is 6. So I will look for something I will multiply with -3 to give me -6 now, and which is 2. So in other words, the first vector here can be 3, 2, then the last one will be 0. So if you multiply these two, you definitely get 0. That's the dot product, because 3 times 2 will give you 6, and 2 times -3 will be -6, then 0 times 5 will be 0. So this will eventually turn to 0, which is what you're looking for to get orthogonal vectors. And then you can try any other one. For instance, let's try another vector, say w. Okay, so I can choose to make my u to be 0 now. So if I make here 0, So I will now do it with this other last two. So all you just need to do is now alternate the values. So I will just make here to be plus 5, and then make this one to be okay, so yeah, just make this one to be 3. That's enough. So 5 times minus 3 is already minus 15, and 3 times 5 is positive 15, and you have a vector that will give you 0. So, and you can as well get a third one, and in that third one you can make the middle one to be the 0. So if I make this middle one to be 0, I will just alternate now, but you can notice that these two now are both positive, so that means one of them here will be negative. So in that case, I'm alternating the number, so I can make this one to be minus 5, and then make the last one, let me remove this from here, so I will make the last one to now be plus 2, or I can make the last one to be minus 2 and the first one to be plus 5. That's another vector. That's another vector already. So using this approach is beautiful and is allowed, because the question says find at least any 2 vectors that will be orthogonal. So you can use this approach to get your 2 orthogonal vectors. Otherwise, there is a hint they have here in your material, and the hint says that you should solve the equation 2a minus 3b plus 5c equal to 0. And how did they get that? They just gave coefficients or variables to these vector values here and equated it to 0. Okay, so and of course in solving this vector you will definitely get what you want. So what do you do to solve this vector? You know, of course, or to solve this equation, you know, of course, whenever before this level we are told you cannot solve an equation with 2 variables if it is only one, that you need more than one. But at this level we know that it's not true, so you can actually solve this particular vector. So what do you do? Make your A the subject, or B or C, any one. So if I choose to make A the subject here, I'm going to get this one crossing over here will be minus plus 3b minus 5c, and that is all over. So I'm dividing both sides by the coefficient of this, which is 2. Okay, so in that case you have actually gotten your solution. So what's your solution going to be? So it's actually going to be something of this nature. Let me put it in a vector form. So the first vector is your A now, which you have made a subject of B and C. So it will be 3b minus 5c all over 2. So that's the first vector. While the second vector is your B, because what will happen is that you will fix your B and C, and then the values of B and C will now help you to get A. So that means my B here will still be B and my C will be C. So this is actually the vector you're looking for, which you can as well label it ABC if you want. I can actually call this my original ABC. So these are the vectors you're looking for. So the first, your A is this 3b minus 5c over 2. See me now, I'm writing over c here. Alright, it should be over 2. Okay, so it should be over 2. Alright, so now what you're going to do to get your values is just to give values to B and C. So I may choose to, let me say for instance, let my B be equal to, say, something like 2, and let my C be 0. If I do that, what is going to happen is that by the time I substitute here, I will then get, of course, this will become 0. This will become 6, and this one will be 0. So you have 6 over 2. So that means A will be equal to 3. And if you watch, you will see that the vector I got is actually the first vector here. Alright? So, and then you can put any value at all you give to B and C will give you a value for A, and that will be an orthogonal vector to you. So if I give my B say 1 and give my C 0, you can see I'm repeating this 0. The reason is so that you don't have to struggle to get the value of this. You can even give your B and C 0 0, you know, and that's a beautiful one. And of course it will give you 0, which is the normal vector that is orthogonal to all vectors. That's the 0 vector. I even forgot that. That's the first one you should have written here if you were smart. So just put the 0 vector. Okay, so, and if I put my B as 1, C as 1, if I substitute here, I'll get my A as this will be 3 over 2, because here will become 3, here will become 0, then you divide by 2. Make sure to check any of these vectors we are getting to see whether they are orthogonal. We've already checked the first one, so we can check the second one and then we'll move on. So in checking the second one, what we want to do is 3 over 2, 1, 0, dot product with the vector you were given, which is 2 minus 3, 5. So you have 2 minus 3, 5. So let's take that dot product. 3 over 2 times 2 will give you 3. Then plus 1 times minus 3 will give you minus 3. And then 0 times 5 will give you 0. Of course, if you add all of this, you are going to get 0. So it's very obvious and very easy to see. Okay, so and that is that for the, so like I said, just give any value to B and C, you will get value for your A. So you don't necessarily have to have the same values. Any of you can get millions of values here, you know, infinitely. Okay, so it's an infinite set. Okay, so let's move on to the next one, which is C. So C, we are told to that vector minus 1, 2, 4. This is what is given here. Minus 1, then 2, 4 dot x minus 5, and then y plus 3, and then x minus 7 is equal to 0. So represents that this now represents the vector equation of a plane passing through. Okay, so if you have this kind of thing and you are looking for, is just, this concept is from the topic equation of planes and lines. All right, so here we are asked to find the plane through which this representation is passing through. Okay, and there is a space there, and of course how to get that the vector where the vector equation that it represents is very simple. Just take all of these parametric equations that you have here and then equate them to 0, or parametric functions. So I'll pick x minus 5 and equate it to 0. That will give me x equal to 5. Let me write it down. So this will give me x equal to 5. Then I'll take y plus 3 and equate to 0. And that will give me y equal to minus 3. And then I'll take, sorry, this last one is z, not another x. Okay, so you have z here, and then I'll take z minus 7 equates to 0, and that will give me z equal to 0. Okay, so now notice that the vector you are looking for, what did I write? Equal to 0, equal to 7. You know, this morning I don't, okay, anyway. All right, so so notice that the vector you are looking for is actually the vector you're looking for here is actually a vector with the entries x, y, and z. So, and that's why we were looking for the values of x, y, and z, and that's equal to 5, minus 3, then 7. So this is the solution for that space that you have there. All right, and then they continued. They said with normal vector. The normal vector is very simple. This is a very beautiful question they're asking you here. So the normal vector is this one that does not have x at all, that is taking that took a dot product with this to give you 0. Remember we said that under dot product, which is one of the applications of dot product, is that when you take the dot product of any two vectors and you're getting 0, then two of them are orthogonal, which is perpendicular, or you can call normal. So now that we have this vector here and it is taking a dot product with this and it is 0, that means this represents the normal vector. So that other space where they said with normal vector dash, so that normal vector is let me write it here. So the normal vector there is that -1, 2 and 4. Okay, so let me read it again. It says the dot product of -1, 2 and 4 with x minus 5, y plus 3, 7 minus z minus 7 equal to 0 represents the vector equation of a plane passing through this one with normal vector this one. Okay, so just to make you get what I'm saying, and that is that for number 4C. So we go over to number 4D. So in 4D it says if a plane passes through a point, okay, so you are given the point P, -1, 3 and 2, and then a vector, so it passes through a point and a vector, and this is the vector v -2, 1, 1. Okay, so if a plane passes through a point and a vector and that plane is perpendicular, let me put it this way, and is perpendicular to this plane. Okay, sorry, if a plane passes through a point this and a vector v is perpendicular, okay, yeah, and a vector v, that's this other vector, is perpendicular to that particular plane, so then its point normal form of equation is given as, all right. So very simple, the point normal form of equation, you know, like I would always tell you that most times when we give you an exam or quiz or whatever, that the solution to some of your problems are actually in the question paper. All right, for instance, looking at this question D, you will discover that the answer is in question C. Okay, so the point normal form equation is this part that has your x, y, z. So in other words, if and then remember I told you that the normal vector is the one in front here. So if this particular v here is the normal vector, so what it means is that if I want to write it in that form of that one in C, what is going to be is -2, 1, then 1 again, dot, then this one now will now form that the normal form of equation, that's the point form of the equation, which is going to be my x minus this, y minus the second component, and z minus the third component. So that's going to invariably give me x minus -2 will be +2, then y minus 1 will be there, then z minus 1 again. Okay, so this is exactly what they are looking for, this one without the normal part. So you can just take away the normal part there, and that will give you what you are looking for in that particular position. All right, so and alternatively, sorry, look at this one is the normal vector here. Sorry, it's going to subtract this part, not this other v here. So what is going to be is x minus -1, which is +1, and then y minus the second component, which is -3, and then z minus the last component, which is -2. Sorry about that. Okay, so and if you want, you can put it equal to 0, or just leave it that way. But then to get your point, to get your point form or your point normal form of equation, that will now finally be equal to, here now you will now use your v here as coefficients for these ones. So that's going to be minus 2 of x plus 1. Then this other one will come plus 1 into y minus 3. And finally you now have plus 1 again into z minus 2. So you're picking this as coefficients of each of these, and then finally you will now equate everything to 0 here. So you have this is equal to 0. Okay, so that's the point normal form equation for the plane that will pass through the point P, which will be perpendicular to a vector V given here. All right, so, and that's what is required of you. Okay, so, and it completes the question for number 4D. Okay, so we go over to the next one, which is 4E. All right, so here we are told that there is a plane, and the plane is minus x plus 7y plus 2z. Okay, that is equal to 10. So they said is a plane that passes through the point P. So it passes through the point P, which is 0, 0, 5. And then with normal vector, okay, so V is a normal vector and it is A, B, C. So they are now asking us to find the values of A, B, C. Okay, so what is our A and what is our B and what is our C? All right, so and that is very easy to see. Okay, what is your A? Like if you come back here, you would see that the normal vector, that's in question D now, the normal vector actually formed the coefficients of these x plus 1, y minus 3, and z minus 2. So assuming I decide to open these brackets, you will discover that the coefficient of x is going to be minus 2, which is the first vector in the normal vector. Okay, and the coefficient of y here is going to be 1, which is also the vector in the second component, and the coefficient of z would also be 1. I'm just giving you the approach that will make things very easy for you if you see questions like this, and which I know we repeat many of the times even in exam. And so that means from this particular equation here, I can easily get my value for A, and that is minus 3, the coefficient of x. Value for B is 7, the coefficient of y. And value for C is 2, the coefficient of what? Z. And you are done. So assuming they asked you to get the normal vector, so that's equal to V equal to minus 3, 7, 2. All right, and that is the solution to that one. Okay, we go over to question F. Okay, so we are done with E. So F says find the parametric equation, all right, for a line that passes through the point. Okay, so we are looking for the parametric equation for a line that passes through the point P1, which is 5, minus 2, and 4. And P2, and your P2 is 0.7, 2, and minus 4. Okay, so right, and then they said the hints. There's a hint given there. Let me point it out. Okay, so the hint is that the vector you are looking for, the vector V will be equal to P1, P2, vector P1, P2 will be parallel to that line. So the vector that will do the job that we are looking for, it says find the parametric equation. All right, so first of all, you need to get the vector that will be normal to that particular equation of plane, so, or the plane itself. So that means this particular one, the hint is saying that this particular P1, P2 will be parallel. So it will be parallel to the plane that you're looking for, okay? Or to the line. Equation, of course, this one is talking about equation of line. All right. So in other words, we need to get the vector that will be parallel to it. And how do you get it? I've shown you that if you're given a 2 points P1, P2, that if you want to get the vector P1, P2, it's just like, remember I told you, although I used A and B, so you are given A and B, and you want to get vector AB. I told you that is simply equal to B minus A. So invariably, this one is going to be equal to P2 minus P1. Okay, and to get our P2 minus P1, we just subtract this. 7 minus 5 is 2. 2 minus minus 2 will give us 4. And then minus 4 minus 4 will give us minus 8. Okay, all right, so that is the value for the normal vector. And then to now get the equation you're looking for, excuse me, so the equation of the line that we are looking for, the line that will pass through P1. Okay, so equation of the line that will pass through P1 is going to be given as, so how do you handle this now? So very simple. So that's going to be x. Remember that equation is going to have x, y, z. So that's the parametric equation. You are going to have the equation for x, the parametric equation for y, and that of z. So three of them put together is the parametric equation of the line that you're looking for. So what's our x going to be? Just follow it. Your x is going to be, you pick the points from P1 and then plus the point in this normal or parallel line to that P1, P2 actually. So, and then you multiply this by the parallel identity T, okay, or parallel parametric variable T, sorry. So here is going to be 5 plus 2 times T, okay. And then what does that mean? It means that my y is going to be equal to, I pick this one, which is minus 2 plus this one times T as well. And then finally, my z is going to become, let me use this one. My z will be equal to, I will also pick this one, the last component, which is 4. Then, of course, plus minus will be minus. So here will be minus 8, and you also attach it with T. All right. So that is the parametric equation for a line that will pass through the point P1. Okay. So all right, and then for P2 as well, so you can use any of them actually, but of course we can make use of this. So if we use P2, so that's going to be something of this nature. So you are going to have x will be equal to, you have 7 plus, of course, 2t as well, comma y equal to 2 now, 2 plus 4t, and then finally you have z equal to, here you now have minus 4 minus 8t, okay. So, and you can always see that it's almost that all of them are the same except the signs here and then this part of x. So here this is the equation of the line that will pass through point P1 and the one that will pass through point P2. So it's important that you take notes of them. And then of course they said it should pass through the two of them. So you can actually write either P1 or for P2. Okay. So, and that is that for F. Okay, and finally in number 4 we have G. Okay, no, there is T, H, and I. Can you imagine? This is there is even J self. It's okay, don't worry, it's good with you. Okay, so let's go to G now. So G says find H so that the planes whose equations are, okay, so look at the equations. So you're given x minus 4y minus 3z minus 2 equal to 0, and another one, 3x plus hy then minus 9z is equal to 7 will be, okay, so find the value of h so that these two planes that are represented by these two equations will be parallel. Okay, so what will be the value of this h in this second equation of a plane that will make the two planes that you are given here to be parallel? And they gave us a hint. They said that if two planes are parallel, then their normal vectors should be parallel to each other. Okay, so in other words, all you need to do is to extract the normal vectors for these two vectors, or sorry, for these two planes. And how did I teach you? You extract that's to extract the normal vectors of a plane. I said you should just pick the coefficients of x, y, and z. So for the first plane, I'm already solving. So for the first plane, the normal vector, let me call it n1. The normal vector for the first plane is, and I think that's what they called it here, is equal to 1 minus 4 minus 3. That's the coefficient of x, y, and z. And they even gave you those two things. And then the normal vector for the second plane, they called it n2, is equal to the coefficient of x, y, and z here, which are 3h and minus 9. And you are done. It's not a big deal. Okay, so here now they said that these two normal vectors should be perpendicular to each other. Should be parallel to each other. Okay, and then okay, so what does that mean? So for the vectors to be parallel to each other, that means there should just be multiples of themselves. And so you can either use that approach, or you can use the approach of cross product. Remember, we told you that if two vectors are parallel, then their cross product should be equal to 0. So I think I would prefer to use that method. So let's look at it. Okay, here we have got something of this nature. I want to look for the cross product of those two vectors and see what is going to give me. So here is my yourself. Okay, come back to, okay, so here is my I, here is my j and my k. So I begin with 1 minus 4 and minus 3, and then here I have 3h and minus 9. Okay, so let's see what it will give us. Remember, this particular cross product should be equal to 0. Okay, so here I will have I into the bracket of minus 4 times minus 9 is 36, and minus okay, so I will now have minus, then minus 3 times h will be minus 3h. So minus minus will be plus. So I will have plus 3h here. Then minus j into the bracket of, okay, so this will be 1 times minus 9, which is minus 9. Then minus 3 times 9 will give you minus 9. And so this will turn to plus. So because you have minus minus 9. So the whole of the center will turn to 0, and then plus k into, okay, you cancel here. 1 times h is h, minus, then here is minus 4 times 3, which is minus 12. So you have minus minus, and so here will be plus. And so everything here will be 0. And recall I told you that whenever you see 0 under vectors, it's not the normal 0 that you know. Don't try us. That 0 is actually a 0 vector. So if you are in a 3 dimension, that 0 means 0, 0, 0. If you are in 2 dimension, that's 0, 0. Depending on the number of dimensions you have, so that gives you the number of zeros you have in a bracket, represented by a single 0. So don't treat our 0 in vectors as your normal real line 0. Alright, so what does that mean? So, and then the implication is that I can equate that 0 there as 0, 0, 0. So, and we are told that for any two vectors to be equal, then their corresponding parts are also supposed to be equal. So I can pick the coefficient of I and equate it to 0, the coefficient of k and equate it to 0. Of course, that of j is already 0, and any of them will give me my solution. And so you are done. What do? If you pick the coefficient of k, which is the simplest one there, h plus 12 is equal to 0, you will get that your h alone is minus 12. Or if you pick the coefficient of I, that is 36 plus 3h is equal to 0, you take 36 to the other side, you have 3h is equal to minus 36. If you divide both sides by 3, you will still get your minus 12. Alright? And that's the value for h that will make those two vectors to be parallel to themselves. And you are done. That is for G. Okay, so here we move over to H. After G, you have H. After G, you have H. Okay, so let's go. Now, question H says that we should find an equation for the plane through the point. Okay, the plane is passing through a point minus 2, 1, and 7, and is perpendicular. Let me use this symbol for perpendicularity. Is perpendicular to the line. Perpendicular to the line. I wish I did this video live. I don't have energy to edit any video. I will upload it like this. Okay, so and is perpendicular to the line x minus 4 equal to 2t. Sorry, equal to 2t. Okay, and then that's not all. Y, where is it? Y plus 2 equal to 3t. Okay, and then finally z equal to minus 5t. Okay, so they are asking us to find the equation for the plane that will pass through this point and that will be perpendicular to this line given by these parametric equations. Okay, so and what is, they gave us a hint here also. They said that the hint that if the line is perpendicular to the plane, then the parallel vector to the line will be normal to the plane, and the parallel vector to the line is, okay, so the hint actually gave the steps of the work you expected to do. Okay, so they said that if a line is perpendicular to the plane, then the parallel vector to the line will be normal to the vector to the plane. Will be a normal vector to the plane, sorry. So they are now asking us to get the parallel vector to the line. So let's do that. Parallel vector to the line. Okay. Parallel vector to the line will be equal to the vector. So how do you know the vector that will be parallel to the line? Remember, if we go up a little bit where we talked about parametric equations, look at it here. Okay, so you discover one thing, that we said that this particular vector here, that's vector p1 p2, that's in 4f. Vector p1 p2 is parallel to the equation of line, right? And how did that happen? That was the vector that formed, let me use this, that form the coefficient of t in the both parametric equations that we got. So you could see the coefficient of t here is 2, coefficient of t here in y is 4, and the coefficient of t in z is -8. Okay, so invariably, what are you expected to do here? The trick here is bring this t to this side and take the constant to the other side. So for x, I'm going to have for x, let me write it. For x, I'm going to have x minus 2t equal to 4. For y, I will have y minus 3t equal to -2. And for z, I will have z plus 5t equal to 0. And these are the parametric equations in their normal form. And once you have achieved that, just pick out the coefficients of t in x. That will be your s component here, which is -2, and then pick out the coefficient of t here, which is -3, and then pick out the coefficient of t here, which is 5. Okay, so this is your parallel vector. However, you can as well leave this t wherever they are and just pick out their coefficients, because of course the sign will not matter, because the only thing the sign will do is that it will just give it a different direction. But in terms of parallel property, whether it's going from south, let me use this example, whether it's going from south to north and is parallel to something, even if it's going from north to south and is moving along the same path, it will still be parallel. So the property of parallel situation between lines does not depend on direction. Okay, so here now, this negative sign, what I'm invariably trying to say is that even if you used your coefficients as 2, 3, and -5, it will still be correct. Okay, so now they now said, okay, the hints now continue. So they say now u is normal to, okay, remember they call this vector u here. So they said u is normal to the plane, therefore the equation of the plane. So to now get the equation of the plane, so we will now make use of our u. And if you go back to what we did earlier here, where we talked about equation of a plane, all right, you will get the relationship between the normal vector and the equation of a plane. But a little bit back to the hint, it says if the line is perpendicular to the plane, then the parallel vector to the line will be normal to the plane. All right, so from there you should be able to form your equation of plane. And how do we get the equation of plane? Okay, so equation of plane is just going to be, now this is how it goes. So you pick your x. So your x will go together with where is the, okay, look at this, the point that the plane is passing through. The plane is passing through here. Let me bring it down. -217. Okay, so so now that equation of plane is going to mean that you are going to, let me put it this way. So it's going to be, remember that the coefficient is the normal vector. So it's going to be 2. I'm using the positive one. Remember I said you can use the negative or positive. It won't make any difference. All right. So 2 will be a coefficient to x. So, and then you will now have that your x, of course, remember that what you normally do here is that x is actually equal to, or somehow should be equal to -2. So when this -2 comes over here, this will now be +2. Okay, so of course you can take away the 0. So you now take this, that will now be together with your 2. And then you will do the same thing for y. So first of all, bring down your 3 as a coefficient, and then your y, you bring in your y here, and then you take this the same way I did here, y is equal to 1, take it over here, so that will give you minus 1, and so this will be y minus 1, and then finally we do for z, your z will be minus 5, and that will be in bracket z. If you take 7 over to the other side, that will be minus 7, and this is equal to 0, which is why I told you that the sign of this doesn't matter. So assuming I used the first one I gave here, that's minus 2x plus 2 minus 3y minus 1, and then plus 5 into z minus 7 equal to 0. If you multiply through by minus here, you will get back the first one. So any of them will actually give you the same solution. Excuse me. So that's actually how to get the equation of plane as required. And then you can try to open up the brackets, and then when you do, you will simplify to get your solution. So let me remove this. So if we simplify this, you're going to have 2x plus 4, then this will be 3y minus 3, then this will be minus 5z plus 35 is equal to 0, and that's going to give us, let me write it down, 2x plus 3y minus 5z. I'm taking all constants to the other side, but let's add them here first. 4 minus 3 is 1, plus 35 is 36. So if it crosses over, it becomes minus 36. And that is your solution to the problem. Alright, and that's for H. So that's for H. So in your material, all you need to do is to fill in your U, the space where they gave for U. When you fill it in, then the next is to now go for your equation of plane. And for your equation of plane, you can actually do what I did here. Okay, so if you do this, you are going to now obtain these ones. Okay, sorry. All right, so I use this to get the values for U. Sorry. Now to now get your equation of plane, so you just fill in this space this way and then solve to this point and stop here. All right, so that is for H. So we move over to I. So this one here, that's I, says we should show that the lines, look at the lines, x equal to 3 minus 2t, and then y equal to 4 plus t, and then z equal to 1 minus t, where your t is a real number. That's what they gave here. Okay, and then they said the lines, okay, they are giving you two lines. These are the parametric equation of the first line, and then for the second line is x equal to 5 plus 2t, then y equal to 1 minus t, and finally z equal to is not z of a Legend of the Seeker. Okay, z equal to 7 plus t is so they said that we should show that these two lines are parallel. Okay, it's the z of the letters of alphabet. Thank you. All right, so let's go. So, and then there is a hint here. Okay, okay, so then it says, then find an equation for the plane that they determine. All right, okay, so now the first thing is that they said we should fill in the gaps we shall leave attempting the solution. So they attempted to give us a pathway, and then they are now giving some spaces which they want us to fill. Okay, so what is the first thing we have here? So we have that let the line 1, which is x equal to 3 minus 2t, all right, comma, y equal to 4 plus t, okay, and then z equal to 1 minus t. And then they said the corresponding parallel vector for L1. Okay, so the corresponding parallel vector for L1. I've already shown you how to pick out the parallel vector for any given line when the line is given in a parametric form. Okay, so that shouldn't be a problem. So the corresponding parallel vector for L1 will be equal to, okay, they gave a space there for you to fill it, so that will be equal to, just pick out the coefficients of t, that's all. The coefficient of t here is -2, the coefficient of t here is 1, and the coefficient of t here is -1. Okay, so that is your parallel vector corresponding to this particular line, and they called it u1. Okay, so and then also you should get out the corresponding your corresponding parallel vector for the second line, which we can call L2. Okay, the corresponding parallel vector for L2 is let's call it, okay, what did they call it? They called it U2 actually. So U2 is equal to the same thing. Try to pick out the coefficients of t in the second line, and those coefficients are 2, -1, and +1. Okay, all right, so you can just see from even what do you call it, the vectors you're given, you should already know that they are parallel, because the values are the same, only that their signs are different. So they are just parallel, going on opposite direction. All right, so, and that's what they need you to show, that the two vectors are parallel, or the two lines are parallel. I think that's the first question. They said we should show that these two lines are parallel. So the two lines are parallel. You can put that the two lines are parallel because one is just a multiple of the other. So once you have two lines are parallel because, all right, one, your u1 is a multiple of u2. You can see that your u1 is actually equal to -u2. That's -1 u2. Okay, so once you have two vectors that have exactly the same values, just different signs, or just multiples, not different signs. Different signs means they are on opposite direction, but they are parallel. But a multiple is just telling you that, okay, maybe this one stopped at a point and then the other one completed the point 2 times. That means this one is a 2 multiple of the other. Okay, so the implication is that, look at this. If I have a vector 4, 2, this vector is parallel to vector 2, 1. Is parallel to vector 1, 0.5, and so on and so forth. So once they are multiples of themselves, then they are all parallel. So it means that they have the same values for x, y, and z, only in different multiples. Alright, so that's enough to show that they are parallel. Now, the second part of that question is that we should determine, where is it? We should find an equation for the plane that they determine. Okay, and they started giving us a pathway as well. So let's try to follow, because there are spaces there that we are supposed to fill. All right, so let me call that second part B. Okay, so there they now said to write the equation for the plane that is determined by these two lines, we do the following. Pick a point on any of the lines, say L1. Suppose we pick the point, okay? So let's suppose, they said suppose you pick the point 3, 4, 1, okay, on L1. Okay, so next, pick 2 points on L2. So we pick 2 points on L2. Call it point 1, which is 5, 1, 7, and point 2. Okay, our point 2 is 7, 0, 8. Okay, both of these are on L2. Okay, so they said now that P1P, okay, the first point is your P. So P1P will cross P2P. Okay, so P1P will cross your P2P. I'm still reading the hints that they have here. All right, and then what does that mean? Okay, and it says that the two of them will be normal to the plane. All right, so they now say thus the vector u is equal to what? So now, first of all, it's normal to the plane. So thus the normal vector u. Okay, so the normal vector of P1. So now they said P1P and P2 P will cross each other, and when they cross they will form normal vectors, and then they are now asking us to obtain the normal vector that they got. And how do you get that? We will do that by taking, let's look at that. We will say the normal vector is equal to the cross product of these two. Okay, so which is going to be, let me write it. So first of all, we need to get our P1P. Remember that here our P1P is going to be P minus P1. So, and that's equal to P minus P1 will be 3 minus 5. That's minus 2. 4 minus 1, 3. Then 1 minus 7 is minus 6. And then again, our P2P will be P minus P2. Okay, which is equal to P minus P2. Let me reduce this and see what it can do for us. Okay, let's just try to manage this space, and then we go again to another page. Okay, so our P2P is P2 minus P2. Sorry, P minus P2. So P minus P2 will be 3 minus 7, which is minus 4. And then 4 minus 0, which is 4. And then 1 minus 8, which is minus 7. Okay, so to get the normal vector, we are going to take the cross product of these two, because the normal vector is a vector that will be parallel to, or that will be perpendicular to the two of them. Okay, so we'll take their cross product. Remember, we told you that the vector that will be perpendicular to any two vectors will be the cross product of those two vectors. Okay, so if we take the cross product of these two, let's go to, okay, let me try to do it up here before going to the new page. So we have ijk, and this is going to be minus 2, 3, minus 6. Okay, so you are going to have down here minus 4, 4, minus 7. Okay, and that's going to be equal to I into the bracket of, this will be minus 21 minus 24, which will be minus 21 plus 24. So here will be 3. I'm doing this crash because of the space. Then if for j, I'll have minus 2 times minus 7 is 14. Then minus, I will now have minus 6 times minus 4 is 24. So, and that's going to give me minus 10. And finally for k, we will have minus 2 times 4, which is minus 8. Then minus 3 times minus 12. Sorry, times minus 4 is minus 12. So you just have plus 12 there, which will give you 4. So the vector that will be normal to them will be the vector 3, 10, and 4. Okay, so let's move over to a new page. All right. Okay, permit me to increase this. All right. Okay, so let's go. So what that means is that now we have gotten the normal vector, and we got it as vector 3, 10, and 4. Okay, so there's a place they ask for that normal vector, so you fill it in there. Now it now says use any of the 3 points we highlighted to write the equation. Okay, so to write the equation, all you need to do now is to pick out the points. Let's go back there. So you pick out the point P. which is this 3, 4, 1. So come back here. So recall that our point is 3, 4, 1. And then what again? All right, so you already have the normal and then you have the point. So all you need to do now is that you are now going to form the equation. Remember how we usually form the equation of a plane. So this implies that the equation of the plane is going to be equal to what? Okay, so here you are going to have this normal vector will form coefficients for, so the first component will form coefficient for x, the second component will form coefficient for y, and the third component will form coefficient for z. All right, and everything will be equal to 0. So what will be inside here? This one will be x. Let me use white. So this one is going to be x minus this corresponding x point on your point P. So here is 3, and then in this case it will be y minus 4, and finally you have z minus 1. And so our equation is, you just solve this. So you're going to have 3x minus 9 plus 10y minus 40 plus 4z minus 4 equal to 0. Collect your x, y, z together. So you have 3x plus 10y plus 4z. Then join all the numbers and take them to the other side. This plus this is, minus 9 minus 40 is minus 49. Minus 3 is minus 53. So if you take it over to the other side, it becomes plus 53. And that is the solution to this particular problem. All right, so problem I looks a little bit long. Okay, go to the previous page. So you know where we started, that you are given 2 points and you are asked to show that they are parallel, so which we did. All right, and after we showed that they are parallel, then they asked us to determine the equation of plane that the two of them can get. So what did you do? First of all, you get out the normal or the parallel vector for the two lines. So the parallel vector for L1 is this, parallel vector for the second one is this. All right, so we now said that their plane is going to be perpendicular to the both of them. So we use the parallel vectors to produce the equation, or sorry, the normal vector. So when we got the normal vector, from there we are able to get the equation of plane that we needed. Okay, so we go over to the last question on question 4. That is J. This is serious. Okay, so question J, we have so you're given a vector v, and v is equal to minus 2, 3, then 0, 6. Okay, and they said find all the scalars k such that find all scalars k such that, let me write that, find all scalars k such that what will happen? Such that the magnitude of kv will be equal to 5. This is very simple now, very, very simple. So all you need to do is you are going to, there are two ways you can do this. It's either you open up the bracket and allow k to multiply your v and then equate it to 5, or otherwise you can follow the hint that they gave you here, which says that you can actually split this into two absolute values. All right, so and so let's use that since it's what they have here, because they used it to ask you a question. So that's going to be our magnitude of k. So where our k is what we don't know, so we put in together with v is equal to, they said is equal to the magnitude of k, magnitude of v, and of course that is together equal to 5. Now, okay, so what do? You now have the magnitude of k times the magnitude of v, where the magnitude of V is equal to what? Or let me do that where down here. Okay, let's do it down this way. So where the magnitude of V is equal to the square root of minus 2 squared. Should I write this? Okay, let me write. Minus 2 squared plus 3 squared plus 0 squared plus 6 squared. I wanted to jump that line, but no problem. So that's going to give us, let me come up a little bit. I can finish that here. That's going to give us the square root of minus 2 squared is 4 plus 9 plus 36. So that's giving us 49, and the square root of 49 is 7. So we have 7 there. So the implication is that if you substitute here, you are going to get that k times 7, of course. This is now 7, so it will multiply the magnitude of k, and that's equal to 5. Therefore, what it means is that the magnitude of our k is equal to 5 all over 7. So it's going to be 5 over 7. Now, since it is magnitude, remember magnitude is the same thing as absolute value. You know I told you that. So magnitude is can also be written, okay, so magnitude can also be written as absolute value, and so you can write this as absolute value of k is equal to 5 over 7. And whenever you have absolute value, remember that absolute value actually can take two values, because if you take the absolute value of a positive number, it will give you the same thing as the absolute value of a negative number. So that means that your k can either be plus 5 over 7 or minus 5 over 7. So this is the value for your k, and that's actually why they said in the question find all the values, because they know it's going to be more than 1. All right, so whenever you hear such things from us, know that we have an agenda. Okay, so the value for k is that, and that completes the solutions for module 1. Okay, and that's a very long journey. Okay, so and that's where I will end this particular video. We will continue in module 2 in our next video. Have a very nice day. Remember to subscribe to this channel. Remember to give comments. Yes, review the video. Tell me, okay, you were fast, okay, and all of that.